Hi guys, welcome back to the channel. So today we are going to be solving today's lead code question, which is smallest string starting from the leaf. So we are given a binary tree which will have the values which are present from 0 to 25, which will represent the integer, which will represent the letters from A to Z. Suppose let's say if we are given 0, then it means that we are given A, and then let's say if we are given 25, then that means it is going to be Z. So we need to return the lexicographically smallest string that starts at the leaf to this particular tree and then ends at this particular root. Suppose let's say this is the binary tree which we are given. Now we need to find the smallest lexicographically made string which will start from the leaf of the tree and then it will end at this particular root. Suppose if we take all these strings, which is going to be DBA and then EBA and then DCA and then ECA, we are going to say that DBA is less than this particular EBA. That's why we are going to return this particular DBA. And then if we take this particular example, if we compare all these strings which are made from leaf to this particular root, then we can say that this is the smallest string. That's why we are going to return this ADZ. And then if we take this particular string, we are going to have ABCC, but we have ABC, so we are going to return this ABC. So if we come to the implementation of this particular problem, we are going to take two strings. One string is going to be our S, where it will take the string of this particular made from root to till the node. Suppose let's say we'll assign answer to empty and then we'll start this from here. Now when we come to this particular place, we are going to say that string becomes, now it is going to become A. And then when we want to traverse left, we are going to traverse left, and then whenever we are incrementing, we are going to take AB, and then we'll travel again to the left. This we are going to travel again to the left, then we are going to say that this is going to be D. Now after completion of this D, this is a leaf node. We are going to check whether this particular node is a leaf node. If it is a leaf node, leaf will get to know whether this particular node is leaf node or not based upon this condition. Like root left should be empty and then root right should be null. Like this should be null and then this should be null. Then we can say that this particular node is a leaf node. Now at this particular point, we are going to take one more string which is same as this particular string, and then we are going to reverse this particular string. Now we are going to get DBA. Now at this particular point, we are going to compare this T with answer. So this is empty, so we are going to assign this answer to the answer, and then we are going to take this out, and then we are going to come back from the recursive call. And then again, whenever we are coming back, we are going to pop this D so that it will have only this particular root, which is going to be AB. And then now we need to call the right. At this particular point, we are going to add E, and then we are going to take this node is going to be our leaf node. That's why we are going to say that we are going to take one more string which is going to be ABE, and then we are going to reverse it, then it becomes EBA. Now we will compare EBA with DBA. Now let's say D comes before E, so we can say that this particular string is lexicographically smaller. That's why we are going to keep this way, and then again we are going to pop this E, and then we are going to take this out, and then again it comes back to previous call, and then again it will come back to here. Whenever it is coming back, we are going to say that we are going to pop this B, and then at this particular point we are going to call this recursive call where we are going to add C for this particular right, and then again we are going to call left, which is going to be like this. And then now I am going to add D, and then again we are going to take the temp equal to ACD, and then we are going to reverse it, which is going to be DCA, and then we are going to compare with this. So dba is less than dca, so we are not going to take this term, and then we are going to pop d, and then again we are going to go back to the previous recursive call, and then again we are going to call with e, and then it is going to be ace, the string is going to be ace, and then temp is going to be ECA. Now we are going to compare. This is greater than this particular answer. Then that's why we are not going to take this temp. And then again we are going to pop this C, and then here we are going to pop C, and then again we are going to pop A. And then at last we are going to have DBA, and then we are going to return the answer. So that's how we are going to do the recursive call. So let us go through the code once. So first we are going to take string, which will store the string which will start from root to till the leaf of this particular node, and then we are going to take root, and then this yes, and then we are going to have answer equal to empty. This is our global variable where it will store this particular answer for from leaf to root. So and then we are going to call find the smallest string. This function is going to give us the answer. So whenever we say we do not have any root, then we are not going to do any operation. We are just going to return. And then we need to add this particular node value which is present. Suppose let's say here we are right now. Now we need to add this particular a to this particular string. So that's why we are going to add, and then we are going to check whether this particular root node is leaf node or not. If it is a leaf node, then we are going to say that we are going to take the temp, and then we are going to reverse this particular string. Why are we reversing this particular string? Suppose let's say if we construct s from here to here, which is going to be a b d. Now we need a string from leaf to root, not from root to leaf. That's why we are going to reverse it, and then we are going to compare it with answer. So we are going to reverse it, and then let's say if the answer is empty, that means we do not have any answer. We are going to add, we are going to assign answer to temp, and then let's say we have answer, then we are going to take lexicographically smaller of answer as well as the temp, and then at last we are going to pop this particular node value which is present. Suppose let's say here we added this particular node value. Now when we come back again, we should not have this particular d. That's why we are going to pop that, so that we can have only ab, and then when we are constructing e, we are going to add abe. So that's why we are going to pop this, and then we are going to return. And then let's say if it is not a leaf node, suppose let's say this is this particular node, this is not leaf node, then we need to traverse this as well as this. That's why we are going to call root left as well as root right. And then at last, after calling root left and then root right, whenever we are going back, we need to pop this character which we added here. So that's why we are going to pop. And then one more function we need to take care is lexicographically smaller. So we are going to have answer and then temp. Out of this, we need to return what is the lexicographically smaller string. So we are going to take minimum of this particular size. There can be different sizes. So we are going to take the minimum of this particular sizes. And then let's say answer of I is less than temp of I. Then we can say that this particular string is smaller than this temp string. So that's why we are going to return answer. And then if temp of I is less than answer I, then we can say that temp is lesser. And then at last we are going to complete this minimum. Now answer dot size is less than temp dot size. Then we can say that this is the smallest string, and then it contains the common string which is same as this. So we are going to return the answer. If it is not, then we are going to return temp. So at last we are going to return answer as our answer, and then we are going to return it. Yeah, that's all for this video. Thanks for watching the video.